Dear students, this episode consists of the following sub-modules: mapping climatic data, isotherms, isobars, and isoheights. Isobars and isotherms. What is an isobar? Isotherms, isobars, isoheights, dew point temperature, isodrosotherm, contouring, temperature contours, pressure and temperature, dew point reports and contours, pressure and dew point, conclusion. Isobars and isotherms. Isobars and isotherms are lines on weather maps which represent patterns of pressure and temperature respectively. They show how temperature and pressure are changing over space and so help describe the large-scale weather patterns across a region in the map. What is an isobar? Isobars are lines of constant or equal pressure on a weather map. They can be used to find areas of low or high pressure over a broad area, and they can tell us how intense the system may be. On weather maps, you may have noticed areas that have a large L or H over a region with lines circling around them. The L stands for low pressure, where we would expect to find the lowest pressure, and H stands for high pressure, where we would expect to find the highest pressure. The lines circling them are isobars. Generally, the lowest pressure is where precipitation is most likely to fall, and high pressures are usually associated with clear and sunny conditions. Where the isobars are close together, windy conditions may be expected. Elongated areas of low pressure on surface and upper air weather maps are called troughs, and elongated areas of high pressure are called ridges.
So, why do we use isotherms and isobars? Isotherms and isobars allow us to view large-scale processes much more easily than looking at the raw data from individual weather stations itself. For example, Figure C is temperature data across the US. Figure D is of the same data, but this time colors and isotherms have been added. Just by glancing, it is much easier to see where the warmest and coldest temperatures will be across the US, and it gives you an idea of what to expect in certain regions.
Isotherms. A line connecting points of equal temperature is called an isotherm. That means at every point along a given isotherm, the values of temperature are the same. Isotherms are represented by dashed orange contours in the weather map. The black numbers are station reports of surface temperature in degrees Fahrenheit, which is the unit for temperature in the US. Most other nations of the world use Celsius. The isotherms displayed were generated from the observed values of temperature and have been plotted at intervals of 5 degrees Fahrenheit. The small orange numbers are contour labels which identify the value of an isotherm, 75 and 85 degrees Fahrenheit. For example, reported temperature values in Nebraska, southern Iowa, and Illinois are generally 90 or above and are therefore located south of the 90 degrees contour. This surface temperature information has been incorporated into a more complex surface map generated for the same time. Reported temperatures show that a dome of very high air has pushed its way into Nebraska, where temperatures are above 90. More pleasant weather is found across North Dakota and Minnesota, where temperatures are in the 70s. The word originates from Greek, where isos means equal and therm means heat. Isotherms are created from regular scheduled simultaneous temperature readings at different locations. For a proper comparison between the observation places, the measured temperature values are corrected for each location as if it was located at sea level. Isotherms help to visualize and interpret the horizontal temperature distribution of an area by showing patterns of temperature on a weather or oceanography map. Constructing a map of isotherms is an elementary step in temperature data analysis, and the process in general is called contouring. It can also be done for other parameters such as barometric pressure, that is isobars, geopotential height, that is isohypsis, dew point temperature, isodrosotherms, wind speed, which is also known as isotax, and salinity, which is isohalines. Isotherms are always smooth, labeled with the values, and mostly parallel to each other. Although the interval between the isotherms is arbitrarily chosen within the same map, it is a constant and usually a round value. The value is selected such that the contour map both contains enough contours to show the patterns, and yet it is not crowded with too many lines. Because data is available only in the temperature observation points, interpolation should be used to create the isotherms between the measurement points. On the other hand, extrapolation to areas where no data is available is not acceptable. An isotherm should never split, cross, or touch another isotherm, because then at the crossing point it would have two different temperature values, which is physically impossible. Sometimes contour maps are enhanced using color fillings when the area between pairs of isotherms is filled with special colors, so a particular color denotes the range of values between the two temperature zones. The relative spacing of the isotherms indicates the temperature gradient, the amount by which the temperature values vary across each unit of horizontal distance in a direction perpendicular to the isotherms. The gradient is larger where the isotherms are closer. From the contour maps, areas of large gradient as well as flat fields can be easily identified. In general, contour lines join areas of equal value of the variable that is being measured and are also known as isoflets. The distance between the contour lines depict the rate of change in that third variable. If the distance between the lines is close, the rate of change is larger over a small distance. These lines are also known as isoflets. There are a variety of specialized isoflet maps. Examples include bathymetric, that is showing sea floor elevation, isohets, showing rainfall, isopax, which show rock or sediment, isotax, showing wind speed, and isobars that show air pressure.
Isobars. A line connecting points of equal pressure is called an isobar. That means that at every point along a given isobar, the values of pressure are the same. Isobars are lines of equal atmospheric pressure that are used in meteorological maps. An isobar map shows the horizontal change in pressure or the pressure gradient that occurs due to the movement of air over large spaces. The isobar map above shows closed isobars around a low pressure system. The black numbers are station reports of sea level pressure in millibars. Isobars are normally drawn at 4 MB intervals with 1000 MB being the base value. The small blue numbers are contour labels which identify the value of an isobar.